Hopefully you've had a chance to try these problems on your own, and in this video I'm going to walk through the solutions. So we have a nail and it's composed of 0.075 moles of iron, and we decide that all of this iron actually turns to rust, every single last atom. And so we were going to try to figure out how much iron oxide forms and also how many moles of oxygen will react with that iron. So the first thing that we need to do is have mole ratios to work with, and looking at my equation, it is not balanced. So I'll go through and balance that first. Looking at my iron, if I balance that with a 2 here, my iron will be balanced. My oxygen, I have 3 in my products and 3 in my reactants, or sorry, 3 in my products and 2 in my reactants. And so the lowest common denominator between these two is 6. If I multiply my reactant oxygen by 3, I'll have a total of 6 oxygen. And if I multiply my product iron oxide by 2, I'll have a total of 6 oxygen. But that means I also now have a total of 4 iron on my product side. So I'm going to come back and I'm going to revise my coefficient in front of iron to be a 4. So that way those balance as well. And these are the smallest whole numbers I can have. I can't divide them all by the same number. So I have a balanced equation. So to figure out how many moles of iron oxide will form, I need to convert from iron to iron oxide. And to do that, I'm going to need a conversion factor that has both of those in it. So I'll use my coefficients to build that conversion factor. 4 moles of my iron, and I'm just taking that coefficient and using that as the base of my conversion factor, will equal 2 moles, again, coming from the coefficient, 2 moles of my iron oxide. So I can set up a one-step conversion using this conversion factor. I start with 0.075 moles of iron. I'm going to multiply it by something to give me units of moles of iron oxide. So I'll input my conversion factor now. I want moles of iron to cancel out. I don't want those units to be in my final product. So I'll put moles of iron on the bottom, and that leaves moles of iron oxide on the top. I'll input the values for my conversion factor next. So I have 4 moles of iron for every 2 moles of iron oxide. And now I can plug this into my calculator. And I'll get a value that's equal to 0.0375 moles of iron oxide. Now, in this next one, we want to know how many moles of oxygen are going to actually participate in this reaction. So now I want to convert to oxygen from my iron. I could also do it from the iron oxide too, but let's just stick with this. So I'll build a new conversion factor using my coefficients. 4 moles of iron, because my coefficient in front of iron is 4, will be equal to that coefficient of 3 in front of the oxygen, 3 moles of oxygen. So again, my starting point is the 0.075 moles of iron. And I want to end with units of moles of oxygen. So my moles of oxygen will be my units at the top of my conversion factor. So that way I keep those units. And moles of iron will be the bottom half of my conversion factor, so they'll cancel out with the moles of iron I'm starting with. And I'll just input my conversion factor values, 3 moles of oxygen divided by 4 moles of iron. And now I will go ahead and multiply this out, and I'm going to get 0.025 moles of oxygen.